Hey guys, I'm going to go over Algebra 2's Unit 4 Part 1 test review. For some reason my radical presentation is not uploading and it's not working. I don't know. So I'm just going to completely start and just go ahead and go over the test review, and I'll focus on that radical part in just a second. Now, most of you have gone over the solutions to this first page and the second page. I feel like you have gotten that. So I'm just going to go ahead and do this matching part and get this taken care of. So 1 through 7, all right? Let's go with number 1, vertical shift down. That is simply saying that you're taking your constant and you're subtracting 2. Remember, the constant is the number by itself. So really we're looking at A and G. So since it's minus and it's shifted down and it's outside, there's nothing opposite about it. All you got to do is choose G. Okay? Reflection over the x-axis and nothing else. That is a negative out front of your radical. That is C. Vertical shift up, you're adding 2. Okay? It's a vertical shift up. You need to be adding 2. So I'm going to go ahead and say it's going to be the other one we highlighted, this other purple one. That's going to be A. Horizontal shift left, that is underneath the radical, that is affecting your x, and that's the opposite of what you think. So that's actually going to be B. Horizontal shift right is going to be E. Okay? This is what number we're looking at, and we're going opposite the direction it wants us to go in. Vertical stretch by 2. Stretch, remember, is the coefficient. So we're looking at letter D. And then number 7, last but certainly not least, a vertical shrink by 1/2. That is going to be F. Hopefully you had great success with that and you got all those answers right. All right, moving on. The next thing we're going to look at is this one right here. Ladies and gentlemen, please, please, please pay attention to this right here. Look at the directions each time, because I will take off a half a point if you don't have the correct index. This number right here, if that is not correct, I have to take a half a point off. Okay. All right, so I'm writing the new function. Stretch vertically by a factor of 7. F of x equals 7 cubed root of x, translate right 1, minus 1. That is your solution. B, reflect over the x-axis. That is a negative. Shrink vertically by a factor of 1/8. Right there. Cubed root, again, translate down. There's nothing affecting my x, so I simply just bring out this minus 4 for our constant. C, f of x equals. Now, they've kind of mixed up the order of what you're doing, so you just need to know that this is going to be x plus 9, this one's going to be a negative out front, and that's going to be a plus 3. That's kind of how I handle those, so I'm just going to put it all together. A negative, there's no other thing other than just this understood negative 1 out front, cubed root, x plus 9, as I had at the very beginning, plus 3. Excellent job. Any questions on those, please ask me before the test. All right, I'm going to continue to scroll down. Nope, if I can, apparently I can't. I'm going to scroll down. There we go. Last but not least, D. F of x, shrink vertically, 1/2, square root, nope, cubed root, got to pay attention to that index, x plus 2 minus 15. I'm going to drop that down so I know it's not added to anything else. Hope that works. Okay, moving on, ladies and gentlemen. This next page, the parent function is always going to be, you just look at whatever index you have. F of x equals the square root of x. Okay? That's always the case. Don't get that wrong. That's an easy thing to just get it. Okay? The transformations from this parent function to this function right here. Okay? we have a 3, we have a -2, and we have a +1. What does that all mean? Well, it's a stretch, a vertical stretch by 3, okay? Then you're going to be going right 2, a horizontal shift, right 2, and then we're going to go up 1, okay? So, those are my transformations. Now I'm going to do my parent table. 0, 1, 4, 9, 16, 0, 1, 2, 3, and 4. That's my parent table. That's an always statement. Go watch the video on the first part of that thing that I do have uploaded. That will tell you. Now, what happens to my x? I'm looking at what's underneath the radical, okay? I'm looking at this x minus 2. So I'm going to take this and I'm going to do the opposite, remember? X plus 2, and then now that I've handled that, I'm literally going to wipe that out, and I'm going to see what's happening, and I'm going to make this my y. So 3y, and then I add that 1, okay? 3 times y plus 1. That's how you can kind of see what's happening to that y, okay? Now, for my x values, I'm looking at these values right here, ladies and gentlemen, those. So I'm going to add 2 to each one of those. 0 plus 2 is 2. 1 plus 2 is 3. 4 plus 2 is 6. 9 plus 2 is 11. And then 16 plus 2 is 18. Now I'm going to take my y values, okay? I'm going to use a different color to help potentially you see this. Y, and I'm going to put that in right there. 3 times 0 is 0. Plus 1 is 1. 3, okay, 3 times 1 plus 1 is 4. 2 times 3 is 6, plus 1 is 7. 3 times 3 is 9, plus 1 is 10. 4 times 3 is 12, plus 1 is 13. Now that I have my ordered pairs, I'm going to plot as many as I can on the graph. My new starting point becomes 2, 1. Ladies and gentlemen, 2, 1. So I'm going to go to 2 and go up to 1. And that's what it's looking like. There we go. I'm going to zoom in real quick, okay? I'm going to zoom this sucker in so that we can plot this. 3, 4. 6, 7, 11, we kind of have off the graph, but I'm going to kind of go ahead and, guesstimate where that is. And now I'm going to draw my line. Do not, I repeat, do not drop below this original starting point. This original starting point, do not drop below it because you are graphing this and you're having an arrow there. This is a hard stop, okay? Don't go below it. I don't want to see an arrow. I will mark it wrong. Don't do it. All right, I'm going to zoom back out. I'm sorry if I'm yelling, you guys. Whoopsies. So now we're going to interpret the domain and range. Okay? The domain, I'm going to write over here. I hope that's okay because I can't really get it down there. But the domain of this function, okay, remember, is all my x values. So I'm literally going to draw and highlight where it starts at the x-axis. And that x value is a number, so it's going to be 2. And then as I continue on, I hit this arrow. That arrow is telling me I'm always going to go forever and ever and ever. I'm never going to stop. So I'm going to say that's 2 to negative infinity. Okay? Now, with my y values, what am I going to do? Well, I'm going to take my y values and look on my y-axis. Remember, the y-axis, you read from the bottom to the top. So, what's my smallest y value? Well, that's at 1. So my range is going to start at 1. And then where's it going? It's going to positive infinity as well. Okay? That's what we have. Any questions? Well, I don't know. I'm in teaching mode. I apologize, you guys. What you need to know and recognize is that in this right here, you need to look at your end behavior. Your end behavior is always going to be this, right here. As x goes to 2, y goes to 1. Okay? And then as x goes to positive infinity, y goes to positive infinity. We use our characteristics from our domain and range to help us answer those questions. Okay? That's very valuable. All right? I can't write that out. I'll put it there in just a second, but I'm going to lose all this as soon as I have this cleared. So I'm just going to go ahead and tell you that. Okay? Again, as x goes to 2, y goes to 1. That's my first end behavior. And then as x goes to positive infinity, y goes to positive infinity. Now, these zeros right here, does it cross my x-axis? No. So you would write none. Okay? That's how you would do those. If you have questions on 9, or was it 10 and 11, which is the cubic function, and another one of those, please let me know in class. I'm not going to go over right now because I want to get to the radicals part, and I want to go have dinner with my husband. So I'm going to hurry this along. Okay, number 12. This is on solving radical equations. You need to figure out what to do. Don't give up. Do what you know what to do. You know you have to get rid of that square root symbol. You know you have to. You have to do it. So go ahead and get rid of it. You're going to take this and you're going to go and say, okay, I'm going to square both sides. This will get rid of my radical symbol, leaving me with x squared equals 8x. Oh my gosh, Ms. Smith, what do I do? Listen, if you have an x squared, you have a quadratic. You need 2 solutions. Stop second guessing yourselves. You can do this. I know you can. Believe in yourself and just start doing something. Just do it, okay? Literally, it's an x squared. You know you have to get a quadratic. Just go for it. Quadratic, you need to set it equal to what? 0. So go ahead and set it equal to 0. X squared minus 8x equals 0. Okay? So now, what I want you to do, once we have this, okay? How did I get that? Just in case you don't know how I got that, I subtracted 8x from both sides. This became 0, and this got incorporated into my now standard form quadratic equation. Okay? So now what I'm going to do is, I notice there's no constant. A constant means there's no number by itself. You're going to go ahead and simply factor out an x. So we now have x times x minus 8 equals 0. X equals 0. This one is right there. And then x minus 8 equals 0. So we're going to solve. Obviously, hopefully you can see that if we add 8 to both sides, x will be equal to 8. So our 2 solutions are right there. You have to check them. Okay? Now, I'm going to go ahead and tell you, since I've done this a couple times, I have checked both of these and they both work. On your papers, you're going to need to show that work. Okay? I'm not going to do it right here because I just don't have space and I don't have time. But if you want me to show you how to solve, I will show you. You just have to ask me tomorrow or Monday. Okay? Cool. That is how you do number 12. All right? I want to do one more. Okay? I'm going to erase this.
Well, okay then.
I want to do, let's see here. I want to do number 17.
Don't tell her to stop, Olivia.
Number 17. We're going to square both sides. X squared equals 2 minus x. Set it all equal to 0. It's another quadratic. X squared minus, I'm going to go ahead and switch signs. Add x to both sides, subtract 2. That all becomes 0. What you do to one side, you must do to the other. So I'm going to do plus x minus 2 equals 0. You have this. You could either use the quadratic formula and find it, or better yet, go ahead and start practicing your factors, okay? You know you're going to need 2 sets of parentheses, okay? And we're looking at -2. Since that's our constant and this is our b term, we need to figure out what two things multiply together to give you -2, and when added together give you a +1? Well, 2 only has this, 2 and 1. So now we got to figure out, where does my sign go? My sign will go with my 1. So it'll be 2 times a -1. What does that look like? Well, we always start our parentheses off with x, and then we come in and say, okay, x minus 1, x plus 2. I know I'm going to have the question, does it matter where I put it? No, you can do x plus 2 first and then x minus 1. It doesn't matter, okay? Set both of these parentheses equal to 0. So our two solutions will be -2 and a +1. All right, now I'm going to come over here and I'm just going to do one checking example, okay? Ignore this for right now. I'm checking these solutions. The first one's -2, the second one is 1. So what I'm going to do is -2, I'm going to put into the original equation. -2 equals the square root of 2 minus a -2. So, ladies and gentlemen, take a look at this. -2 equals 2 plus 2. -2 equals the square root of 4. What's the square root of 4? It's 2. Does -2 equal 2? No. So that means that -2 is, you guessed it, an extraneous solution. It's extra. Okay? An extraneous solution. So that is not a solution. Now we just try number 1. Try it. It's probably going to work, but just in case it doesn't, let's give it a shot. What's 2 minus 1? Oh, that's 1. Does 1 equal 1? Yes, because the square root of 1 is 1. So the only solution for this problem is x is equal to 1. And that is your final answer. Okay? If you have questions, please feel free to email me and group me it. Aspen, put it on Aspen, just let me know. I can go through a couple more. I'm going to go eat with my husband, have some dinner, and then I'll be back around my computer around probably in about an hour and a half, all right? So probably around 9 o'clock, and I can help you out. Just let me know. All right, happy studying. I'll talk to you guys soon.